Hey, welcome to AP Chemistry. One of the things I want to get started, because it will be a constant part of AP Chemistry and of this class, is with labs. Now, you might have heard some of the things like this before, uncertainties, or the unavoidable error that we see in investigations. So there's two sources of this unavoidable error: the data table and the procedure. You can look at these well before we ever do any kind of investigation. So in the data table, these are linked to precision, and they're based upon the device being used to measure. These are unavoidable. Every kind of measuring instrument has a level of precision which is estimated to a certain value, or what you might remember as significant figure. Now, if it's an analog device, meaning not powered, doesn't have a digital display, it's half the smallest increment. Some things, like glassware, will say what its precision is. It might be like plus or minus 5% for things like beakers. And for things like volumetric flasks, it might be plus or minus 0.01 milliliters. Those are very precise. But if you're using something like a ruler or a graduated cylinder, whatever the smallest increment is, it's half of that. So if the smallest increment is 0.2 milliliters, then it's plus or minus 0.1 milliliters. So analog, half the smallest. Digital device, investigate what it is. Sometimes you can look these things up and it will tell you in the directions or the manual. Other times we kind of just go with the smallest increment it has, but you can always look it up. Each measurement is an error, so they should be used explicitly. So if you have 5 mass measurements in a series of one trial, those are 5 separate errors, 5 separate uncertainties that you should take note of and be able to acknowledge how could we improve those. The only way to really improve it is to replace it, to change it out with something that is more precise. Because again, if the issue is with the device by its lack of precision, the only way you can do that is change it out with something that is more precise. And again, this has nothing to do with accuracy. This is like the number of decimal places that you can measure to. The procedure, quite different. These are systematic errors that are part of the system. The procedure that prevents you from determining the most accurate values. So this is part of, I'm doing everything right, but I'm not going to get the best value based upon what the procedure says. These are also unavoidable. If you're following the procedure, you're just doing as it says. There's no rule to follow for these type. It's a little bit more that you have to use logic and deliberate practice, meaning that while you're doing this, you have to think about it. Not just, I'm going to do the lab, blah, 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 and then, oh, wait, what are the errors? You need to think about it. You can think about it before, during, and after, once you have the experience of the lab as well. So how to improve these? Like I said, when it comes to the measurements, we think of the uncertainty. So like this scale would measure to the hundredths, which means its uncertainty could be in the hundredths. This scale measures to the, is that 100,000, 10,000, 100 thousandths of a gram, much more precise. So instead of using this scale, we would improve and use this scale as a replacement. But again, we want to be explicit, not just get a better scale, because that's misleading or vague, but why is it improved? Talking about the number of decimal places. So taking it to a higher level of precision and making it clear that you understand what that means. As far as a procedure, these can only be used by changing actions in a procedure or something else that's non-measurement equipment. So for example, if we were to say we wanted to make a saline water, salt water, I would mass out the amount of salt, put it in the water, boom, we get it. However, there will be some loss of salt because some of it will inevitably stick to our weigh boat here. So there will be some loss and not 100% of the salt gets in there. So this would be one that would be less precise. How could we improve it? Well, we could take the salt and let's say take the mass in the water itself, lacking any kind of transfer. We could also use the spoon that we're measuring it out and taking the mass and maybe stir it instead of this stir rod. So the stir rod may be a worse idea because some of it will stick. Or again, alternatively, we could rinse out the weigh boat with water in order to get all of that salt transferred and dissolved. So this would be a change in the procedure in order to make an improvement to where we'd have less loss in this case of transfer. Transfer is often a predominant area where you can have unavoidable error because inevitably not everything transfers 100%. So we're going to do an activity in class, just get you a little feet wet. Of course, we'll be working on this all year long as we do all of our labs, because a lot of these questions come up in AP, in science, and of course on the AP test at the end of our year. Let me know what kind of questions you might have, and see you soon. Take care.